Hey y'all, it's Shelly, and for this video, we are going to record journal entry number 8, looking at One Way Anovas. So in this demo, we're going to conduct a one-way ANOVA with post-hoc tests if necessary to compare staff satisfaction scores across 3 levels of length of service. So before I get started, like always, I want to take some time and go through the data set. This data set is called staffsurvey.save. It is from Julie Pallant's SPSS Survival Guide. And if we come over here to the variable view, we can look at 30 different lines of things that we're measuring. So we have a survey questionnaire based on 30 different items. The last variable we looked at, our column width was 8, and this one's 3. Some of our videos and demos, we've had 2 decimal points, and this one we have 0. Typical are labels. As you can see, there aren't very many labels here. We've worked with this data set before, and to figure out questions 1A through questions 10A, we had to go back to the actual original survey set. So like always, our level of measurement is here. So now we're going to go into our data set. And we can see various things measured, and I won't go all the way down, but there is a huge amount of data. Although we have this many participants or this many data set, once we weed through data and clean out data with missing components, we'll see that our data set is a lot lower. But for now, let's get back to talking about ANOVAs. So, as I said, we are going to conduct a one-way ANOVA with post-hoc test if necessary to compare staff satisfaction scores across 3 levels of length of service. First, we're going to pick a test. We are using the analysis of variance or ANOVA because we have multiple levels within our independent variable. Since we have more than 2, a t-test is not appropriate. The independent variable is the length of service, which is divided into 3 groups. And remember, we just said multiple levels within our independent variable. So these 3 groups are 0 to 2 years of service, 3 to 5 years of service, and 6 or more years of service. The dependent variable is our staff satisfaction scores, which are measured at scale. So this means that they can be calculated. Second, we will now check our assumptions. And there are 4 assumptions for an ANOVA. Number 1, random samples. Number 2, independence of cases. Normality and homogeneity of variances. The sample is not random because all staff was asked to participate. There are more than 30 participants, so it is, however, robust. Independence of cases. Each staff member responded individually without the influence of other staff members. For normality, we use SPSS to run a frequency distribution and histogram. Then our homogeneity of variance to be determined after we run the ANOVA in SPSS. So first, we check our normality. And to do this, we go into Analyze, Descriptive Statistics, Frequencies. We're going to move our dependent variable, which is total satisfaction, over to our variable box. Under charts, we're going to choose histograms. And we're also going to choose to show the normal curve on the histogram. Then we're going to click continue and OK. We come up with some data here. We notice that we had 491 valid and 45 are missing some piece of data set. So looking at our histogram, our scores look fairly normally distributed. Our actual data is normally distributed along our bell curve. So our first three assumptions are okay. And to check our last assumption, we need to run the ANOVA. So we're going to go to Analyze, Compare Means, and One Way Anova. And I'll show you that looks like Analyze, Compare Means, and One Way Anova. I'm not going to click on that because I'd actually previously done it. And I'll come back up here to what I had received when I ran it. Before I actually clicked it and ran it, I had to click on the dependent variable, which is the total satisfaction, and I moved it to the dependent list. Through these videos, we have gotten very common with taking something from a left side and moving it to a right side box. Our independent variable, there was a length of service in group 3. And what this does is, like we talked about earlier, the 0 to 2, the 3 to 5, and the 6 or more years of service, it breaks it down. And we put that length of service group 3 into the factor box. And actually, I think I'm going to take a second and go ahead and do this again, simply because there are quite a few steps to this. So if we went to Analyze, Compare Means, One Way Anova, it's just easier for me to show this. We took our total staff satisfaction scale and moved it to our dependent list. And then our factor was length of service group 3. So you have to be careful, because if you were just measuring length of service in general, you could use this one. But we have to scroll down and look that towards the bottom down here, actually right before this age recode into 4 groups, there was a length of service grouped into 3. We selected that and moved that into our factor box. We then went to options, and under statistics, we clicked descriptive, homogeneity of variance tests, the Brown-Forsyth test, the Welch test, and the means plot. We excluded cases missing any sort of value or data by clicking on this radio button for exclude cases analysis by analysis. And of course, our confidence interval is set at the standard 95%. So we're going to click continue, and then we're going to go into post hoc. And this is just in case, because as we've learned, sometimes you need post hoc and sometimes you don't. But we are going to go under here, under equal variances assumed, and we're going to click 2 key. Then we're going to hit continue. We're going to hit OK. So now we're going to kind of go through and explain charts. And because I did it, it's actually the same charts listed again down here, but that's okay. So let's go through and take a look at some of these charts. Before we actually start analyzing charts, we need to set our hypothesis and our null hypothesis. When we learned in Dr. Cooper's class, you can't really hypothesis shop. You've got to set this ahead of time. So, in listing out our hypothesis, Our null hypothesis is going to say that all three of the population means will be the same. And our alternative hypothesis will say that at least one population mean is different than the others. Now on to step 4, we're going to set a decision rule. We do this by finding the critical value of F, which is the value that separates the rare zone from the common zone of sampling distribution. Our decision rule says that if F is greater than or equal to the critical value of F, we will reject the null. And if F is less than the critical value of F, we will fail to reject the null. So to find the critical value of F, we use K minus 1. K is our number of groups, which is 3, because we have 3 different groupings of service levels. And N is the number of cases. So we use K minus 1 to determine the degrees of freedom, which you'll see right here is 2. We use this for our denominator. So our numerator is K minus 1, which is 3 minus 1, and that's equal to 2. So the denominator, sorry, I misspoke, which is 432, which is the total minus K, or 434, which is the total minus K, which is 3. So we have our denominator, which is actually 432. And so it should have been 435 minus 3, or 434 minus 2, rather. And then we get 432. And this is important to know when we use both of these numbers, that when we're looking at the chart in Appendix A12, and we look at the intersection of column 2 and the number 432, the numerator and the denominator to get our critical value of F. In this case, it is 3.018. Our decision rule is that if F is greater than or equal to 3.018, we will reject the null. And if F is less than 3.018, we will fail to reject the null. 3.018 is used to separate the common zone from the rare zone. Now we're ready for step 5, which we have actually already done, and that's running the test statistic. So we're to the final step, interpreting the results and also checking that the last assumption, homogeneity of variance, that we put off until later. So let's look at that first, that final assumption. We can go to Levene's statistic right here. Test of homogeneity variances. And this information here, if greater than 0.05, then our assumption is met and okay. And all of these are greater than 0.05, so we've met all 4 assumptions. Now we must interpret our results, and we ask 3 questions. The first one, was the null hypothesis rejected? So in looking at our ANOVA chart, we see that F is 5.902. And remember, our number from the chart was 3.018. And so 5.902 is greater than 3.018, so we will reject the null hypothesis. F falls in the rare zone, which means at least one of the groups differs in mean satisfaction, and which indicates a statistically significant difference. So our second question is, how big is the effect? And we calculate R squared, and we use the sum of squares info in the ANOVA chart. We take the between groups value, that is the 557.061, and we divide it by the total, which is 20,944.069, multiply it by 100, and we get 2.6598. Then we multiply that by 100 to get a percentage, and the effect is very large. It's 265%. That's really, really large. Then our final question is, where's the effect? And we will need to run the post hoc test, which we did. Remember, we did that initially just in case we needed it. So we come down here to look at the total staff satisfaction scale under Tukey. And as you can see, I'm just kind of scanning through some data. There's the curves we looked at earlier. And here is our robust test, our Welch and our Brown Forsyths. Here's our eta squared and epsilon squared. And here's our ANOVA chart. Here's our test homogeneity of variances using the Levine statistics. And these were our descriptive statistics. So if we start looking at our groups, we can see that groups with 3 to 5 years and the groups with 6 or more years are significantly different than groups with than the group with less than 2 years. And if we come down and look at our chart, we can see a big difference also from year 3 plus years, that those means are really close. But you can also see that 2 years is significantly different. That less than 2 years is significantly different than these two down here. So we know which group is now different, and we know that there is a very large effect size. So in summary, the test has revealed that those with less than 2 years experience had satisfaction ratings that were significantly different than those with 3 or more years experience, and those employed 2 years or less have higher employee satisfaction rates. You can look here at the differences. Here's our Tukey. And this is what we were looking at, our 6 plus, and then our 3 to 5, fairly close, but a difference. And then you look at that less than or equal to, and that's a huge difference. So we look at our significance level, it's high. So if we start plotting our means, I actually like putting this stuff in a graphic. It's much easier to see. We have our satisfaction scale ratings and then our length of service. So if you look at employees with less than or equal to 2 years of service versus employees with 3 to 5 years of service versus employees with 6 plus years of service, once we represent this graphically, we can definitely see the huge difference in means, and we can see the significant drop, which is statistically significant, between employees that have less than or equal to 2 years and then those from 3 to 5. And then the decline continues in a downward negative trend, but it's not as drastic as this. So whereas these scores mean a lot to a statistics student or a statistician or somebody reading a research type article, if we were making a point to a common layperson or we needed a quick means of reference to show what we were looking at, this graph is very, very powerful. And there again is our histogram. So what looked like normally distributed scale amongst the normal bell curve, we can see actually is interpreted in a large statistically significant difference. So thank you for joining me. And next time we will look at some more ANOVA testing.